to identify the frequent dislodgement of the conveyor belt due to various reasons in the hilly terrains. To solve this problem, we use Lidar technology. Lidar means light detection and ranging. This Lidar technology is generally used to identify the topology of the Earth's surface. This is the Lidar. Here we can see that the IR rays comes out of the Lidar sensor and they strikes the surface of the conveyor belt and they gets reflected back onto the camera. This camera is high resolution camera which is capable of getting the XYZ coordinates of the conveyor belt. And when they are converted into the graph, here we can see that the y coordinate changes, which indicates that there is some misalignment or some wear and tear in the conveyor belt. This is how we use Lidar technology for our problem. Now let's look into the design of the prototype.
Here is the prototype of our project. This is the conveyor belt. These are the rollers through which the conveyor belt rotates. Now let's get into the project first. We harness the power of technology with the Lidar sensors in the fabric of the conveyor belt. At first, let's talk about the positioning of the Lidars. We strategically installed two Lidars, top and bottom of the conveyor belt. At first, when the conveyor belt is in motion, then this Lidar scans the lower surface of the conveyor belt. This Lidar scans the upper surface of the conveyor belt on its return journey by emitting infrared rays. The emitted rays can interact with the conveyor belt and reflected back. Then this can be captured by our camera system. We'll get a 3D point cloud data then. Here the magic happens. If the conveyor belt is in precise condition, then we'll get a smooth uniform plane. If there is any wear and tear or debris remains on the conveyor belt, then we'll get irregularities and distortions in the graph. We have developed an ML model which can analyze these type of intricate shapes and patterns of the 3D point cloud data. So based on these shapes and deviations, we can predict whether there is a risk of dislodgement of the conveyor belt or not. So let's get into the ML model.
Before talking about the machine learning model, let's start by discussing the data we'll be obtaining from the LiDAR sensor. This data is commonly referred to as point cloud data. It represents our conveyor belt in the form of points, each containing x, y, and z coordinates. To illustrate this, here's an example of the point cloud data, which we'll be collecting from our LiDAR. Reading this point cloud data is pretty straightforward with just a simple Python code, and this data can also be integrated into our programs. However, to effectively predict even the smallest wear and tear from this huge dataset, which contains at least 100,000 data points, we need a machine learning model. So, for our solution, we chose PointNet++. PointNet++ isn't just a standalone machine learning model. It's a neural network architecture tailored for 3D data processing. Since PointNet++ is primarily designed for processing and classifying point cloud data, we are using it to process the data which we obtained from the LiDAR. The provided code defines PointNet using TensorFlow, which we use for processing point cloud data. We can load our data and labels, configure the necessary hyperparameters, and proceed to train the model. Once the model is trained, we can utilize it to make predictions about any misalignment or wear and tear of the conveyor belt using the new data which we collect from the LiDAR sensor. Let us have a quick recap. In summary, we have a normally functioning conveyor belt. The LiDAR continuously sends data to the machine learning model, which evaluates the data for the predictions. If the model detects any issues, it promptly sends an alert to the control room. Subsequently, the control room dispatches a maintenance crew to perform the necessary repairs, and they ensure that the conveyor belt is restored to its normal operation. And that's all about conveyor vision. We are Team Strategies, and thank you for watching our video.